Yes. So, like for example, we have given a second order filter.
And sir, one more thing, how to identify the type of filter?
Uh, what you are asking, please wait a minute. Just repeat your question. Yes, please repeat your question.
How to identify the type of filter, sir?
Okay. Uh, so what we can do in to identify the filter? Wait a minute. Okay. Like for example, this is my circuit VI R1 R2, that is C2 and C1. Okay. If I find the transfer function V out upon Vi, okay, so that particular transfer function is in the terms of 1 upon 1 plus alpha s plus beta s square, like in this way. Okay. Now, if you see that there are two particularly RC circuit is there. One RC circuit is this one, R1 C1 combination, and one RC circuit is this R2 C2 combination. There are two capacitance, so we can say there are two, because the capacitance impedance is, what is the impedance of capacitor? C1, if I am taking, it is a 1 upon C1s, and if I add C2, that is a 1 upon C2s. Okay, and if these two are in cascade, so there are term is 1 upon C1 s into 1 over C2s. So that's why there is a term of 1 upon s square C1 C2. Okay, so that's why this s square term, so we can say that this is the second order. Clear? Okay, now if we solve the transfer function V out upon V in, that particularly is the 1 upon 1 plus alpha s plus beta s square. Now I compare this one with the equation of second order. Generalized equation is 1 over 1 plus s upon omega p qp plus s square upon omega p square. Okay, now I compare these two equations. So what is the value of omega p square? That value is 1 upon beta. Okay, 1 upon beta. Okay, so from that one we calculate the omega p is nothing but 1 upon root beta. Okay, so this is the formula for calculating the cutoff frequency. Okay, for the second order, generally we are taking the cutoff frequency. Fc is 1 upon 2 pi. If there are the two different resistance and capacitance, so it will be the R1 C1 R2 C2. Okay, and if R1 and R2 are equal, similarly C1 and C2 are equal, so Fc is nothing but 1 over 2 pi root of R square C square, that is 1 upon 2 pi RC. Okay, in this way we can calculate the cutoff frequency. Okay, if we have
We
to
can directly use
identify,
the
if we
we
have to
can use directly
identify
the formula,
the,
sir.
yeah,
We can use the direct formula for cutoff frequency.
not exactly directly formula. You can do one more thing is here is that is upon dependent on the question. Okay, what we are calculating is that, like for example, we are taking that this filter is a second order low pass filter. Oh, sorry, this is the omega p. This is the omega p. Okay, now let's assume that we have a second order low pass filter. So what is the response of the low pass filter is that for the lower frequency the magnitude is high, and for the higher frequency the magnitude is tends to zero. This is the general response of the low pass filter. Okay, how it will be different from the ideal low pass filter? The ideal low pass filter is that it will be behave like this one. Okay, assume that transition band from the high pass, so for the pass band to the stop band is transition from the pass band to stop band is exist on a single frequency, that is called the cutoff frequency. That is the ideal response. Ideal, but practically the response will be the blue one. Okay, so what we assume that it will be the pass band. Okay, we can say it is a stop band. From that one it is a stop band. For this one it is a pass band, and this one is called the transition band. Okay, it is called the transition band. So this particularly practical low pass filter response will be divided in three bands: pass band, stop band, and the transition band. Now, how we define the cutoff frequency? Either we define the cutoff frequency of this one, either we define the cutoff frequency of this one, or either we can define any cutoff frequency between the transition band. Okay, so what we assume is that if the magnitude of the particularly response will be down, like for example, if I'm saying this is the one magnitude, so if it is a 1 upon root 2, or we can say if the magnitude is down by the 3 dB, that particularly point is called the cutoff frequency. So this point where the magnitude will be dropped up to the 3 dB, this particularly point is called the cutoff frequency FC. Okay, clear?
Yes, sir.
Now, how we solve the particularly cutoff frequency value? So, like for example, we solve this one and transition function V out upon V in is this one. Now we calculate the magnitude. So for magnitude, what we do? We put S equal to j omega. So V out upon V in is what? 1 upon 1 minus. Now S square is the j omega whole square. So j square is minus 1. So minus beta omega square. Okay, plus alpha j of omega. Okay, and what is the magnitude of this one? So V out upon V in. If I take the mode of this one, so the mode of numerator and mode of denominator. So mode of numerator is 1. What is the mode of the denominator?
1
1
minus
minus
beta
beta
omega square
omega
whole
square
square.
whole square plus alpha omega whole square and root of this one. Okay, and we know at the cutoff frequency the magnitude will be the 1 upon root 2. So if V out upon V in is down at a 1 upon root 2, if I put the value is 1 upon root 2, or the maximum upon root 2. Okay, maximum upon root 2. Okay, so we can say this particularly with this particularly omega is not nothing but the cutoff frequency. So this omega is nothing but the omega c. Okay, now the thing is that how we calculate the maximum. How we calculate the maximum? So if it is a low pass filter, so the maximum magnitude appears at omega is equal to 0. Okay, maximum magnitude appears at omega is equal to 0. So now if I put s equal to j omega, so v out upon v in is equal to 1 over 1 plus j alpha omega minus beta omega square. Now put omega is equal to 0. So if omega is equal to 0, this term 0, this term 0, so it becomes a v out upon v in is 1. So this is the maximum. Okay. Now if v out upon v it, like we are getting the a naught. If v out upon v in is a naught upon 1 plus alpha s plus beta s square. So what is the maximum magnitude? That is the a naught. Okay. Now what we do to calculate the cutoff frequency, we are putting the a naught by root 2. Okay. Clear?
Yes, sir.
So in this way we can calculate the cutoff frequency. Now the second question is that how we identify that this particularly is the low pass filter or the band pass or high pass filter or band pass filter. The best way is that you can put values. Okay, the best way is that you can put the values. Like for example, we are getting the V naught upon Vi is equal to A naught S upon 1 plus mm, like I just put as a 2S upon 1 plus 3S plus 4S square. Simple, I just take. Okay, this is the V naught upon Vi after putting the value of R, C, and everyone. Okay, now S put S equal to j omega. Okay, so V naught upon Vi is what? 2 j omega upon 1 plus 3 j omega minus 4 omega square. Now put omega is equal to 0. Okay, so omega is upon 0 is V naught upon Vi is 0. Put omega is equal to infinity. Okay, so we can't solve this as it easily. So V naught upon Vi, what I do, I just take a omega square common. So 2 j omega upon, so 1 by omega square minus 3 plus 3 j upon omega minus 4. Omega will be cancelled out with the omega. Okay, now this term is 0, this term is 0, this term is minus 4. So 2j upon minus 4 omega. Now omega is again infinity, so it becomes 0. So lower frequency, okay, lower frequency it is a 0, higher frequency it is a 0. If you set the any other value, the value will be like this. Okay, like in this way. Intermediate frequency, the value will, particularly the graph will be like, because at the lower frequency it is a 0. At a higher frequency, infinity it is a 0. Intermediate frequency is between, so the magnitude will be increases. So the response is band pass. Okay. If you set V naught upon Vi is equal to 2s square upon 1 plus 4s plus 6s, like this way. Now put again s equal to j omega. So it is a minus 2 omega square upon 1 plus 4 j omega minus 6 omega square. Now put omega is equal to 0. So V naught upon Vi is 0 by 1, that is 0. Okay. Now put omega is equal to infinity. So V naught upon Vi, what I do, I just take omega square as a common. So minus 2 omega square upon omega square, so 1 by omega square 4j by omega minus 6. These two cancel out. Now put omega is equal to 0. So minus 2 divided by minus 6. That means 1 by 3. Not 0. Okay, not 0. Any particularly value. Okay. So the response will be like that. At 0 frequency, it is 0. At a higher frequency, the magnitude will be like that. Okay. So that too is the high pass. Okay, clear?
Yes, sir.
Any other doubts?
Sir, week 10 practice assignment question 3.
Week 10 practice assignment question. Wait a minute. Mhm. Yeah, this one.
Yes, sir.
Now, what is the load regulation?
Sir, the change of V out when I load is 0 and I load is maximum.
Okay. So basically, what it is given that hmm, our input voltage will be changed from 3.2 to 4.2. So what is the load regulation is in milliampere. Okay. So first we assume the input voltage is 3.2. Okay, V in is 3.2. So if V in is 3.2, what is the current that is flowing from this particularly branch? Yes. Yes, any idea what is the basically current that is flowing?
Sir, V in minus V on upon total resistors, maybe.
Yeah. So the value of current that is flowing from, if I say this is the current I, so it is a V in minus V on upon total resistance RT. Okay, so that is 3.2 minus 1.5 divided by 20k. So it is a 1.7 divided by 20k, that is 0.085 milliamp or 85 microamp. Okay.
Yes,
Now,
sir.
now if we are saying the 85 microampere current is flowing from this particularly branch, so what is the voltage drop across this one?
Sir, multiplied by 10.
Multiply
This,
by 10.
yeah.
So that is 0.85 volts. Okay, and the voltage of this one is the 1.5, so that means the voltage drop from this point to this one is 2.35 volt, and the remaining voltage will be drop here. So 3.2 minus 2.35 is 0.85 volt will be drop. Okay,
Yes, sir.
now we change the V in as a 4.2 volts. So I just change with the color. Okay, so 4.2. Now the current value is again V in minus V on upon RT, that is 4.2 minus 1.5 divided by 20k, that is 2.7 divided by 20k, it is a 0.135 million. Okay, if 1.135 milliampere current is flowing, so that means the voltage drop across this resistance is 1.35 volt, and voltage drop across this particularly point is 2.85 volt. Okay, the remaining voltage will be dropped here, and the value of this one is what? 2.85, 1.35. Okay, so it becomes a, what is the difference in the voltage drop across this resistance is 0.5. Okay, now if I connected one load resistance with the short circuit, this is my load resistance that is connected as a short circuit. Okay, So if the difference when I change the input voltage, the difference across this voltage, this particular resistance is 0.5 volt. So the what is the current that is flowing from this one is del of I. If del of V is, I say that this is the A resistance, so del of VA is what? 0.54. So what is the del of IA? 0.5 divided by 10k.
Yes, sir.
So it is a around 500 microampere.
Okay, sir. Thank you so much.
Any other doubts? Any other doubts? Any doubt related to the week 1 to week 11?
Sir, quiz 1, question 3, part 1.
Is one. Hmm, I just stopped my sharing. Quiz 1, question 3.
Sir, just the part 1.
Okay. Hmm, yeah. This is the combination. This one?
Yeah, yes, sir. Just the first
Okay.
part.
Yeah. So identify the configuration of third operation amplifier. So what is the configuration of third operation amplifier? We see that this one is the negative feedback. This one is the negative feedback. How this one will be the negative feedback? If this symbol is minus, this symbol is plus. Only you have to identify, na. So when the negative feedback will be coming.
Sir, I do not get the concept of like applying these marks and about finding out how do this gives the negative feedback.
Okay. So basically, if you see that only one loop is creating between looping is what? What is the relay when we are getting some output in the feedback of the input? Okay, or we even combine the feed output in the with some multiplication factor and connect it with the input. So this is the feedback. Okay. Now, if you see that in this particularly part, the voltage, like for example, we are saying the V1 voltage. Okay, there is no relation between the V out and V1. Okay, and we are saying that this is the V2 voltage. So when the V2 voltage will be coming at this point, some particularly output voltage will be coming from this way. Okay, so that means at this point we are getting some voltage V2 plus minus V naught is the output, correct voltage, actual voltage. If you apply the KCL, so you are getting the KC in the KCL part, you get some particularly V naught terms here for the when you apply on this particular node.
Yes, sir.
Okay, so the second thing, if you are getting that, if I break any loop, like for example only one loop is created here. Okay, if I break a loop, this one loop, okay, if I increase the voltage, okay, so the voltage that will be increased, like for example I increase the 1 volt, so when the voltage will be passing from this one, there are some voltage drop, so here we are getting some increased voltage that is lesser than 1 volt, but there is the increase, that means positive voltage is there. Okay, now that positive voltage come at this point, that means this is the again a positive voltage. Okay, now if I multiply this with the positive signal, that means we are getting a positive voltage here.
Yes, sir.
Okay, now we apply some positive voltage and we are getting back a positive voltage, that means this is not a negative feedback.
Yes, sir.
Okay, so how this will be negative feedback? If I
When
multiply
there
this
is
positive voltage with the negative.
negative.
Okay, if I multiply this with the negative, so we are getting a negative voltage. Okay, now this one is created a 180-degree phase shift. That is a negative feedback. Okay, so if this is a negative, this one is the positive. Okay, generally
Yes, sir.
what we study is that operation amplifier op amp always work in a negative feedback. Okay,
Yes, sir. Thank you, sir.
only a certain cases where operation amplifier will work as positive feedback. The one is the estimate trigger, second is oscillators. Okay.
Yes, sir. Sir, could we discuss the first question's first part also?
Yeah, this one.
Yes, sir.
Again, we have to identify the negative feedback. Again, we have to identify the op-amp configuration for negative feedback. So here we see the negative terminal. Here it we see the positive terminal. Okay, so the when V out is coming from here, it will be go in two way. One is this one, and one is this one. Okay. Now V
Yes,
out
sir.
that is coming from this one. There is a voltage drop across this one. There is a voltage drop across this one. So we are getting a V out. Uh, like for example, there is some voltage drop, so we are getting a alpha V out voltage here. Okay, the value of alpha is less than. Okay, and when we are going with this way through the operation amplifier, this is the positive, this is the input resistance, this is the feedback resistance. So what we are getting, because of the operation amplifier, we are getting a minus of RF by R1 into V out. Okay, so we are getting a minus beta time V out because of this circuit. And what is beta? Beta is RF 40 divided by 5, that is beta is 8. So beta is greater than 1. So at this point, what we are getting? Negative voltage. Negative voltage, because one is
Yes, sir.
current that is passing from this one operation and one through the operation amplifier. So we are taking the alpha va naught minus beta v naught. The value of alpha is less than 1 and the value of beta is greater than 1. So this particular term is greater than this one. Okay, so we are getting a negative voltage. Okay,
Okay, sir.
now this negative voltage will be come here at this point. Okay, now if I multiply with the negative voltage, so negative voltage also there, and negative voltage it become a positive voltage. So we are getting a positive. Okay,
Okay, sir.
so
Thank you, sir.
if we apply the positive voltage and we are getting the positive voltage, that means there is no negative feedback. This
Yes, sir.
particularly feedback is a positive feedback. So what should we do? If we this we multiply this negative voltage with the positive voltage, we are getting a negative voltage. We apply positive voltage, that means this one is a negative feedback. Okay, if this terminal is positive, that means this terminal is negative. Okay,
Yes, sir.
any other doubts? Any other doubts? No doubts?
Sir, can you please solve the mock question number 6?
Mock question number 6. Which mock?
This term mock, sir.
This time you have to try that one, na? First you have to try that. After that we will solve that.
Okay, sir.
Okay, if I solve that, then why the mock is given? Okay, that is for you. It is
First we will
uploaded.
solve.
It is uploaded on your portal.
Yeah, just now, sir.
Okay, so you just try it initially. Okay, after try
Okay,
you can solve. You can basically share the solution on a G space to me with me. I will check it. Okay, and
okay, sir.
if you, any problem in that one, I will solve that, or we can schedule any class before Friday also.
Okay, sir. Sir, can you give some hint how to solve B part,
Mm,
operating
yeah,
frequency
I
of
will
the circuit?
do that. Yes, this is a single stage configuration. Okay, so if I say that this is the VI, this type of question you already solved in the week 3 assignment.
Yes, sir.
Okay, so basically this is the C. This is the combination of parallel R1 and R2. Okay, so what is the formula? If I take that this particularly combination is 1 upon 2 pi, f is nothing but 1 upon 2 pi rc. Okay,
Sir, your
rc.
screen is not visible.
Okay. Okay, so what is of f? F is nothing but 1 upon 2 pi rc1. Okay, now what is r? If I remove this capacitance, so what is the equivalent resistance of r is that these two resistance are in parallel. Okay, and that will be series in this with this resistance. Like this is RS. Okay, this is RS. So we are not considering this RS. We are only considering the parallel combination of this 10 and 10K. So what is the R? R is nothing but 10K parallel with 10K. Okay, so it is a 5K. R is 5. Okay, if R is calculated, can we calculate the C1?
Yes, sir.
Okay. Similarly, this particularly combination will be giving me the frequency, operating frequency of the circuit. Okay, so F is nothing but 1 upon 2 pi R L into C2. Okay, RL is what? 1K. F is already given, so C2 we can calculate.
Okay, sir, got it.
Okay, if you have any other doubt, you can go with the V3 contained part, where we can limit the capacitance value, capacitor limit.
Sir,
Any
any
doubt? Yes.
sir, any similarity with the end term of Mach?
Yeah, somehow. Not exactly, somehow.
Just like quiz 2.
Mm, Quiz 2. Yeah, Quiz 2. Now the thing is that in the end term I am giving only the 5 questions. Okay, in the mock I am giving 7 questions for the practicing.
Yes, sir.
Okay. So and yes, you can see that around somehow similar. Not exactly, somehow similar. Similar to the Quiz 2. Okay.
Okay, sir.
Any other doubts?
Sir, in the mock question 4, there are not the subparts given.
Only question is given. Mm, Yeah, you can write down the particular subpart, or I can send in the group again, G space again. Okay, I will send in the G space again. Okay, I just upload it also
Sure,
this
sir.
time. That is missing. Okay, any other doubts? Just any other doubts? Any other doubts? No doubts?
Sir, in graded assignment 10, the fourth question did not had the actual values of R1 and R2. So you said that it will not be evaluated, right?
If no problem, then can we wind? Yes, just Dhruv.
Sir, actually, my doubt is regarding experiment 4. I asked you in G space
Mm,
how to get that derivation.
mm. Dhruv, can I check and confirm it's still night? Because actually you sent me a message, but after that, due to some emergency, I have not worked it out on that one. So
Yes,
till
sir.
night,
Yes.
I will inform you. Okay, I will reply
Yes,
your
sir.
query. Okay, just wait for till night. I will just inform.
Excuse me, sir.
Yeah.
Sir, in graded assignment 10, question
Mm,
4, earlier you said that the value of R1 and R2 isn't given, so this question would not be, used in evaluation, right?
yes.
तो सर एक्चुअली हमारे इस क्वेश्चन की वजह से मार्क्स कटे हैं सब स्टूडेंट्स के.
Wait a minute. Week 10 grade assignment for 1, 2, 3. Mm, the marks is 0 point. Can I show my screen? Just wait a minute. Can you see this particularly graded assignment question number 4?
यस सर.
The point is 0 points.
सर एक्चुअली मेरा इसके अलावा और कोई क्वेश्चन गलत नहीं था एंड स्टिल आई गॉट 88 आउट ऑफ 100.
Mm,
Same
I
for me,
just
sir.
I just confirm that they revalued this one or not. Okay, I just asked the supporting because when we have to reevaluate them, they have to regenerate the score again. Okay, so I just confirm this one with the support team.
ओके सर.
Okay, but this is a 0 point.
ओके सर. थैंक यू सर.
Maybe they are not reevaluating the marks again. Mm, I'll just drop a mail to the support team. Mm, Okay, I just sent ask to the support team to kindly push the updated score.
Okay, sir. Thank you, sir.
Anything else? So I think if no doubt, so we can stop here. You just start your mock exam